amplify signals from the environment. It has to help us handle situations where there's a lot of information available and we're not able to process all of that. Let me give you two examples here. One is the OnStar system that you get in Cadillac cars. It's produced by General Motors. When you have a collision, the OnStar system automatically detects the inflation of the airbag, sends a message to the OnStar centre, and they get back to you and say, "Are you okay, sir or madam? Can we send assistance to you?" Here they're amplifying the signals from the environment that could be thousands of miles away, and then they can provide you emergency medical services. Another example from the car industry. This is a product being developed by Toyota. People can fall asleep at the wheel. Toyota have a capability where they can put a camera on your eyes and detect whether you are starting to fall asleep. That is, they amplify those signals and then they send a message to you to wake you up. Right? So you may not be able to detect that you're falling asleep. In fact, your consciousness is gradually drifting away. You have less ability to process the signals from the environment. So one important role of technology for us as humans is to amplify the signals from the environment in important situations. The other side of it is attenuation. There are so many signals in the environment that we want to turn some of this processing over to technology and do it for us. So there's the easy pass system with some toll roads in the US. You don't have to slow down and pay the toll. You have a system in your car and you can keep going. Or even a credit card. Think about the difference between processing a payment when you hand across cash and with a credit card. When you hand across cash, you have to first of all count it out of your wallet or purse, give it to the person, and then you check the right amount of change and you put it back. With a credit card, all you need to do is look at the amount on the card, the amount that's charged to the card, and then sign off. Far less processing is required. In fact, there's an Englishman called Warwick who's taken an RFID chip and embedded it in his body so that as he walks around his university, doors will open for him, right? He can focus his attention on more important things and be the true professor and lost in the world of thinking. In fact, because he's English, he's embedded a chip in his wife so they can share emotions. But I suggest only the English need that. I hope there aren't too many English people here, you know. It's a great Australian tradition to take fun out of the English as much as possible. But they also enjoy it. So, just to back off, two fundamental things that we need technology for in our modern life. To amplify certain signals from the environment and attenuate some so that we can manage our life in this complex environment with a Stone Age operating system. So then, what's a global information system about? It supports decision-making and the operations for a person over space and time throughout the environment. We amplify and attenuate information to free up conscious information exchange. So what's the core goal of an information systems in this global world? The central activity of a modern organisation is decision-making. Those of you who are about to graduate soon will spend your life making decisions. This is what organisations do. What's critical is that we make good decisions. Therefore, organisations seek knowledgeable people. That's why you're getting a degree. You're accumulating a certain amount of knowledge, and you need that knowledge for two things. First of all, knowledge gives you the capacity to determine what information you need to solve a particular problem. And knowledge gives you the capacity to interpret what that information means so that you can make a better decision. And before all of that happens, you need data. So the lifeblood of decision-making is data. We take it through a process of converting data into information, and then knowledgeable people can take that information that they've requested and turn that into a decision. So we need to look at these elements of data, knowledge and information as to how they fit together in globalisation. From a data perspective, what we're observing these days is digital data genesis. That is, most data is born digital these days. For many organisations, it's just happenstance. It happens as part of the daily processing of the organisation. For the really alert organisation, they are starting to build this into their operations so they collect more data about their customers. Let me give you another example. If you are a frequent gambler and you go to the casinos in Las Vegas or Atlantic City, you can get a frequent player card which you can put in the slot machine. This means the casino can work out how much money you lose, and the more money you lose, the more valuable you are to them as a customer, and then they can decide whether to give you a free flight or a free hotel and all these other sorts of things. However, the casinos have a blind spot for one particular aspect of gambling. What about those chips when people play roulette or card games? They don't have any information there. They can collect it. The pit bosses can write down information, but it's a slow and tedious process. Casinos want to capture that information because that's where a lot of money is lost. Right? You can see I have a fairly realistic view of gambling. Right? It's about an exchange of money in which you, the gambler, lose. The casinos want to know how much money people lose at roulette and the card games. So what have they done? They've embedded RFID tags into chips. So when you gamble with cards and things like that, they can record exactly how much money you lose. Because they've recognised that digital data genesis, which I think is one of the ideas that will emerge over the next couple of years as being important for organisations, is to work out exactly what information you need about your customers or suppliers and then design ways of collecting that in a digital fashion. So it's very easy to collect and very inexpensive. The other things we need from a data perspective are standards. If two organisations exchange data or a group of organisations exchange data, we need a standard for it. And the way we have that in most products these days is with XML, which is a language for defining the format of data exchange between organisations. And then in terms of data conversion, we have SQL, which some of you might be learning, and business intelligence software. Critical issue is how do you take all the data that you collect from something like a data genesis strategy and turn it into information that you can use as a knowledgeable person to make decisions. So that's the data side of how it fits. It gets much messier when we talk about information and knowledge from a global perspective, because it's very dependent upon language. Which language do the various parties speak? What's the culture of the two groups? Culture is sometimes a barrier to understanding people. What's the education level of the two people? Do they speak the same sort of technical language or business language? And then what's the context? Where are they talking or exchanging information? Let's look at some of these elements from a global perspective. First of all, the problem with language is it's a local information system. It's not something that's spread across the world. We have thousands of languages, and we don't understand many languages beyond our native language. Fortunately for us, English is the global information systems language. It's emerged as the way in which many business people and many scientists exchange information. It's the language of opportunity. If you want to get ahead in many countries around the world, you learn English. And that gives you an entree to the business world and the scientific world. It's also the corporate language. So some years ago I did some work for the Finnish Trade Commission in Finland. I was surprised to discover that their language, their official language for all operations, is Finnish. Because in some countries they employ people as trade commissioners because of their local knowledge who don't speak Finnish. The corporate language of the combination of Renault and Nissan is English. One company is a French company, the other is a Japanese company. The language that's common to business people in both companies is English. It's also the language of science. That means that you, as a native English speaker and writer, have a comparative advantage in this global world today. It also results in a disparity. English speakers produce and English writers produce a lot of the science and the business knowledge of this world. And then many other people have to read it. They're at a disadvantage because it's not their native language. And so you find some parts of the world where very little is written in their native language. And as a result, they consume mainly English. Let's have a look at what these native languages are. So what do you think this one is? Mandarin, right? A particular form of Chinese. In fact, China has many different languages. Mandarin is the formal version. Or here we have Hindustani, commonly spoken in India. So what do you think this one is? Spanish, right? And finally, English, the language of opportunity, the language of business, is the fourth largest language. The fifth one is Arabic. So these are the languages that are spoken around the world. And notice that English, though it's dominant in the business world, is the fourth most spoken language. Now, you might say, well, this is not a problem. We can always use machine translation. Why do we have computers? Because they can do these mundane tasks for us, like translating languages. The machine translating people have gone through 3 generations. They still haven't really solved this problem. First of all, their naive view was that you'd have 2 dictionaries and you just exchange words. That doesn't work particularly well. Most languages have an ambiguity score of about 2. That is, for a word in one language, there are 2 choices in the other language. The extreme is Arabic, where there are about 20 choices for one word in English and going into Arabic. Then they decided, well, that brute force approach didn't work. Let's analyse. Let's do a lexical analysis, parse the thing, and try and sort it out. That requires extensive linguistic knowledge. Lots of ambiguity, didn't work. The most successful approach we have these days is something that you get in Google Translate. They take the approach of machine learning, where you just feed in lots of documents that are in both languages, right? So people like the UN and the European Union have taken documents in one language, translated them into the other, so you have a pair of phrases that have been translated from one to the other, and you just feed that into the computer, and that's how you do the translation. If you want to try out machine translation, then use Google Translate, because that's the system it uses. And if you really want to test it, take an English sentence or 2, translate it into some other language, and then take that language and translate it back into English, and you'll be discovered that it might be quite different. This is a major problem for us. If we want to be able to communicate with each other, we would like to have efficient machine translation at the level of the cell phone or something like that. We are still some way from solving that particular problem. This is a tremendous opportunity for developing the sort of information systems at a global level that we need. Another approach is to say, let's accept that English is the language of opportunity, the language of employment, but it's complicated and difficult to learn English. So the Voice of America developed in 1959 something that it calls Special English. This is about 1,500 words. It's used to describe basic emotions, actions, and objects. You get rid of idiomatic statements, you use simple sentences, and it's fairly good at communicating. This is the translation of an interview that I did with Voice of America about 18 months ago, describing something called the Global Text Project. And so they took that, we had the interview, they took it, and they represented it as simple English, and then broadcast that, and then supplied the text on their website for people around the world. Actually, I run a project, and you can read there, about the Global Text Project. I'm concerned that many students in the world can't afford textbooks, particularly in the developing economies. So we have a project where we're getting students to work and faculty to work on creating free textbooks. Now, this was incidentally quite successful. We got lots of contacts from different parts of the world. Some organisations have adopted Special English as their standard form of communication. So I've read of Chinese companies that have decided that it's very difficult to teach everybody English, but you can teach them the 1,500 words of Special English. That becomes the standard way of written and oral communication in the company, and you can solve this communication problem without resorting to machine translation. So there's a lot of value in this. The Dutch have Special Dutch, and they are translating many government documents into Special Dutch because the majority of Dutch people aren't well enough educated to read the sort of legal statements that governments produce. The Australian government is doing a similar thing. Special Australian, I think it's called. What about culture? This is another barrier that we face in global information systems. And in many ways, culture is a part of the global information system. It's a global information system, or I should say a local information system, for defining behaviour. You learn as a child to behave in particular ways when interacting with other people. It's the software of the mind. We all start off with the same sort of brain, but in those early years, we get a culture derived from our parents and grandparents and other relatives that programs us to behave in a particular fashion. Layered on top of that is a professional culture. At your university, you start to get training in your particular discipline. So if you're an accountant, you learn the culture of accounting. What are the things that you value in accounting? Well, accuracy of records, separation of control and those sorts of things. If you're in information systems, you learn another set of cultural values that we believe are important. The integrity of information, the importance of innovation, the importance of listening to people to determine requirements and so forth. Every one of you is getting trained in a particular professional culture. And that's something that's been developed by your profession over many years, and it forms part of your behaviour when you operate as a professional. And then the corporation lays on top of that its particular culture. Now, one of the things that I find a little bit annoying is that every now and again we get a disaster like Enron or the behaviour on Wall Street, and some people go back and say, well, it's a problem of business schools. They don't teach integrity and they don't teach ethics. That's not where the problem arises. The problem arises because the corporations set standards for culture. They set their standards by who gets rewarded. In Enron, the people who were a bit shady, who didn't quite follow the rules but that made a lot of money for the company, were the ones who got rewarded. And that became the culture of the company. I think it's too much to expect universities to teach integrity and ethics when it's the corporations that have to demonstrate that day in, day out by whom they reward and whom they promote. So we have these three different sorts of culture that affect your behaviour. If we look at national culture from a comparative perspective, and there's a reference here to where I've taken this from, but I just want to point out a couple of things here. I've highlighted the difference between the Anglo culture, which is that of North America, Australia, New Zealand, Great Britain and so forth. The culture that most of us inherited either from England or in the immigrant societies that we joined. And then the Confucian culture, essentially the culture of China. You notice that they only really differ on a couple of elements. We tend to be a fairly individualistic society. We believe that self-interest is what matters. And this is the way to resolve a lot of issues in society. So the free market is about self-interest. If you look at the Confucian approach, the Chinese approach, it's much more about collective interest. That when you make decisions, you think about the greater group to which you belong. Otherwise, these two cultures are quite similar. But what does this mean to you when you go and work in another culture? If you go and visit China and work there, you have to think differently about the way in which you approach decisions, because in that culture, you have to think of the collective needs rather than just the individual needs. It's very important to have roadmaps like this to help you operate in other cultures. And there are some very good books around that will help you when you go to another culture, say, these are the key features of your culture. When you go into this other culture, this is what's important. And this is how you start to behave. So this is part of the global information system that you need to accumulate to operate in a global world. So then if we look at behaviours and decisions, how do they come together? Organisations create a corporate global information system that feeds information into a national information system, and then the behaviour and decisions of people based upon the information that they receive is dominated mainly by national culture with some influence from their professional culture and also the corporate culture. It's these elements that come together that result in behaviour and decision making in organisations. So the corporate global information system is just one element of the total process by which decisions get made in a global corporation. Now let's move on and look at another aspect of this. Why do people want information systems? In particular, what are the main characteristics they want from these information systems? And I believe that there are 4 fundamental drivers. People seek ubiquity, uniqueness, unison, and universality. Let me explain each of these. Ubiquity is the drive to have access to information unconstrained by time and space. That's why we love our cell phones. You can get messages no matter where you are in the world, provided you're on one of these international systems like GSM. The physical counterpart is the ready availability of physical resources. That's why we love cars, because you can hop in your car and you can tailor the trip to your needs. That resource is ubiquitously available. Uniqueness. We want to know precisely the characteristics and location of a person or a particular entity. This is why we like navigation systems and GPS systems. Now, these have been long-term goals for people. One of the problems of 17th century life, if you were a sailor, was you didn't know where you were in the world. You could work out your latitude, but you couldn't work out your longitude. And the British government had a major prize to create the GPS system of the day, because this was a competitive advantage in trade. Well, the GPS was developed by the US as a competitive advantage in warfare. It's very important for a troop or a group of troops or soldiers to know precisely where they are. On the physical side of it, we want products that are tailored particularly to our personal needs, such as mass customization. So here's an example of a bike with many different components that you can put together to create the perfect bike. Unison means that we want informational consistency. So I use something called Mobile Me so that my calendar on my cell phone and all my computers is the same. My department has a calendar for everybody so that we know what the department events are. We want a single view of information. So when people teach database, they talk about a single integrated view of the data. This is a long-run goal of humans, to have a single correct source of data that they can access from a whole variety of different places. From a physical point of view, it's procedural consistency. That is, if I use an ATM in any part of the world, it's the same procedure. That I can pick my language and then I go through the same process. These are long-term goals that people have. They drive the underlying features of information systems that we have and physical systems that we have. And finally, there's universality. In the case of information, we want to reduce the friction of incompatible information systems. About 5 years ago, if you were a fully fledged nerd, you carried around a belt full of devices. Some of you may have remembered that. What did you have? Your GPS, your music player, your PDA, and your camera, and your phone. And they didn't talk to each other. One of the great reasons that the iPhone is successful is it's integrated all of those. So that when you take a photo, the GPS works in parallel with you, with the camera, to say where that photo was taken. It's not a case of taking a photo with your camera and then looking up your GPS device and somehow writing that piece of data down. We don't want that. We want universal appliances that have all of the capabilities, and we don't have this friction between the various information systems. It's the same thing at the physical level. We want to reduce the friction of physical differences. One of the great developments in the shipping industry was the standard container. Developing a standard size, and then you can design a whole system around that. One of the unfortunate things about the development of Australia as separate colonies, there were 3 different railway gauges in Australia. If you wanted to move something from the west coast to the east coast, you started off on a 3-foot 6-inch gauge in Western Australia. You got to the next state, it changed to 4-foot 8.5, and then the next state was 5-foot 3. You would have to change trains all the way around. You couldn't ship an item across the entire country without having to change trains. Very expensive system because of the friction of physical differences. And this is one of these things we're trying to get out of the world through things like ISO. This is part of what makes globalization successful. We can reduce these informational frictions and physical frictions to make the world more efficient. Now, let's put all of that together. I've talked about the need to attenuate and amplify signals from the environment. I've talked about the 4 U's. We can put all this together and we can start to brainstorm the sorts of opportunities of the systems we need in a modern global environment. Let me give you some examples. The Hyperreal. This is where you're ultra-conscious and unique. A good example here, I got from some students in Saudi Arabia. One of the great problems they have there is nobody wants to go out and inspect a drilling rig in the middle of summer. It's just too hot. And so the drilling rig would fail, or the well would fail, and nobody would know about it. It becomes very costly. So what do? They connect it up to the internet. You drop a line down the well, you transmit that information back to an air-conditioned room, and suddenly you can monitor all your oil wells very easily. So you are hyperreal in the sense that you know much more about the oil well than you did previously when you visited it every few days. And then there's the posthuman, ultra-conscious and unique and ubiquitous. Here the OnStar system is a very good example. It permanently enhances the information that you have about the use of the car and the current state of the car. So that in the example I gave, when there's an accident, it automatically detects the inflation of the airbag and communicates that information and so forth. We are moving towards this permanent enhancement idea. The cell phone permanently enhances your capability to communicate. We might have advanced prosthetics in the future that will improve your capability. Already there are artificial legs that people have been able to use to run faster than normal athletes. And then maybe there's genetic enhancement in the future. So we change the genetic composition of our body to give us some post-human capabilities. Already there's a major industry in body change and changing the shape of your nose and other aspects of your body. In this case, the network is always on in the post-human environment. Then we look at the matrix, unconscious and ubiquitous. Here we want to move tasks from conscious to unconscious. Remember, we have limited processing capability. Sorry for the odd cough. We want automated consumption. We have limited capacity to process all the information from the environment, hand some of these over to technology and let them do it for us. So in Singapore, they have congestion pricing. Well, you don't want to stop people and charge them as they come into various parts of Singapore. What they do is they create this grid of 50 gantries across Singapore. You see a photo there. When you go through one of those, the smart card in your car is automatically charged the current price for accessing that part of the city. And it varies dynamically. It's more expensive early in the